All right, here's problem number 29 from section 8.4. This integral is improper not because there's a infinity sign here, but rather because natural log of x is not defined at 0. So we'll need to rewrite this using the limit notation. The limit as a approaches 0 from the positive side of the integral of from a to 1 of x natural log x dx. Now, you may recall that this form, x natural log x dx, is one of our integration by parts, where u is equal to natural log x, where dv is equal to x dx, where du ends up being 1 over x dx, and v equals 1/2 x squared. So our rewrite of this ends up being 1/2 x squared natural log x minus the integral of 1/2 x squared times 1 over x dx, or 1/2 x squared natural log x minus, pull the 1/2 out, integral of x dx, 1/2 x squared natural log x minus 1/2 times 1/2 x squared plus c, or 1/2 x squared natural log x minus 1/4 x squared plus c. We'll take that antiderivative and bring it back into our normal flow. The limit as x approaches 0 from the positive side of 1/2 x squared natural log x minus 1/4 x squared is evaluated from a to 1, or the limit as a approaches 0 from the positive side of 1/2 1 squared times the natural log of 1 minus 1/4 times 1 squared minus 1/2 a squared natural log of a minus 1/4 a squared. Now, natural log of 1 is 0, so that whole thing goes away. Looks like I've got negative 1/4. Over here, I've got a plus 1/2 a squared natural log a, and I've got a negative 1/4 of a squared. That's going to go to 0 once I apply the limit. But what happens here when I apply the limit? A squared goes to 0. Natural log a goes to negative infinity. That's indeterminate. Let's do a little bit of side work here. On the side work, we're going to ask the question, what is the limit as a approaches 0 from the positive side of a squared natural log of a? This is indeterminate in the form of 0 times negative infinity. So I'm going to rewrite that as the limit as a approaches 0 from the positive side of the natural log of a over 1 over a to the negative 2. Now this is L'Hopitalable in the form infinity over infinity. I can use L'Hopital's rule then to get that this is 1 over a divided by negative 2a to the negative 3. Now, ugly algebra, but we should be able to handle this. And that is going to be a to the negative 1 minus a minus 3. And then there's the negative 1/2 that goes right there. So when I clean this all up, I get the limit as a approaches 0 of a squared. There's negative 1/2 in there, and that's equal to 0. So there we have it. When we apply the limit to this expression, I get negative 1/4. I got this going to 0, that going to 0. I believe the answer is negative 1/4.